Right, welcome back. We're continuing describing motion of moving objects, moving bodies. Now, we have just come to a particular equation now that we can use to find solutions around motion of objects that are having constant acceleration, okay, moving in a straight line. So we're not looking at objects moving, in more than one dimension. We're looking at motion in one dimension. Okay, now that first equation we spoke about is this one here. Okay, V final equals V initial plus A delta T. All right. Now you must note that these are equations of motion that we use to solve problems related to motion. And every time a question is given to you, it will be in such a way that one quantity is not there. Okay? So you'll have to look for it. But then the equations themselves, on the other hand, are given independent of one of the quantities. Now, if I have, for example, if I look at this first one, remember the quantities we spoke about? We spoke of displacement, we spoke of velocity, we spoke of time, we spoke of acceleration. Okay? And in terms of velocity, we're talking final and initial as well. So all those quantities, have them in mind all the time. And when you look at an equation like that, you would see that you've got final velocity, you've got initial velocity, you've got acceleration, you've got time. Now, what is missing here? This equation is independent of displacement. In other words, if you have got a question based on motion and you are not given the displacement and you are looking for another quantity which is not displacement, this is the equation to go for, because you can be able to calculate for that quantity. Say it was V final or it was delta T, and in the information you don't have displacement. This could be used, and that's how you eliminate these equations to know which one to use, because you can't use all of them in a particular situation. One will definitely apply, and if you're lucky, you might have two applying, but one of them will apply. So it is very critical for you to choose the right one to use in solving that problem. The next one, delta x, and this is obviously if we're talking about motion along the horizontal plane. Delta x is given by V initial delta t plus half A delta t squared. Now, this equation here is independent of final velocity. You don't have to have final velocity to know the displacement covered by this object here. So if you don't have the final velocity and you are asked to find the displacement or the initial velocity or acceleration, you can use this equation here. But you can't take any other equation that has some final velocity, because that is not going to help you. Okay, so what you would need to do if you are given final velocity, look for other equations that will apply, because this one would not apply in that situation. The third equation, we have got this one, V squared, V final squared equals V initial squared plus 2A delta x. Okay, now this one is independent of time. All right, so you can work out the final velocity, you can work out initial velocity, you can work out acceleration, you can work out displacement, depending on what is given to you, without time given to you. So you must know that if I'm not given time, this is the equation to use. If I'm not given displacement, that is the equation to use. If I am not given final velocity, that is the equation to use. Okay, and the last one, okay, it's not completely written here. You'll see that dot there meant multiplied by something, so something didn't come off as we set this up here for you to see. But then here is displacement delta x equals delta t. This is the one that works with average velocity. Now, you would remember that the word average refers to something you add up and you divide by the number of items you've added up. This time we are adding up the final velocity to the initial velocity. How many quantities are we adding up? We're adding 2, so that's why we're dividing by 2 to get the average. Okay, and if we do that, we will get the displacement covered, or the displacement of that object. And this equation here is independent of acceleration. That is important for you to know. See you in the next section.